Hello everyone, this is my fourth demonstration video. In this video I am going to explain the functional with technical part of our second microservice which we have built, that is the PayPal validation service, and I am going to explain about all the flow of this microservice and why we need this microservice and how we can implement and what we are implemented in this microservices. So as the name says, this is the PayPal validation service. So basically it is the first service uh, which is built in our payment system. In order, I can say that the first is the validation service, the second is PayPal processing service, and the third one is the PayPal provider service. So in the third demonstration video, I have already explained the functional and technical part of PayPal provider service, which we are already built. So now I am explaining about the PayPal validation service. So the basically in this service we are we have main focus on the building of the first security, and the second one is the exception. So first, the major parameter is security. Why security? Because it is the first endpoint. uh, as I say before, that this is the first microservice, and its endpoint is visible to our external service or external client which is going to call us. So that's why the security is very important in this service, and all other services also need the security, but those are the internal services, means the one service and communicate to another service. So basically it is the internal part, but the main external or the end point, I can say that major factor is this payment validation service or PayPal validation service, because by this service our e-commerce client firstly call this validation service, then we call after processing and doing some technical and functional part, then we call the payment processing service, and after that payment processing service call the payment provider service, and then provider service call the actual PayPal system, means calling the PayPal APIs like three API, that is create, capture, and also the get order. So firstly, in this validation service, we are implementing the HMAC-SHA algorithm in security purpose. So our main focus, two main focus of this validation services, to maintain the data integrity, maintain the security, and also checking the request we got, we request body we got from the our client or outer services, the fields which are necessary to process or in the calling of PayPal APIs. I will show you that what are the request. So to validating those request, like it is proper or not, it is quite null, and when when there is any bad request comes, or when there is any null request that is mandatory, and our client is not passed us, so we have to handle those exceptions also. So what are the response of our uh, program, like it is terminate, we should handle them. So basically these two main factors of this payment validation services, the first is the security and second is the validation and checking the fields with proper exception handling. So firstly, I want to talk about the security. Then after that, I will explain about the exception part or exception handling part. So firstly, I am going to explain about the security. So we are, as I say before, we are implementing the HMAC-SHA256, which is very a famous security algorithm, and it is basically in current time used by very large amount of developers because it is secured and very trusted algorithm, and it is very easy also to implement, and that the method and the technical part, I can say that the working of this algorithm is very nice and very strong, so intruder could not break it. I can explain you that. So let me first explain about the HMAC overall explanation, then I will show you the code also, that the what is how I implement the HMAC SHA in our algorithm, in our code. So firstly, what is HMAC SHA? That is a algorithm, means I can say that when the request is coming, okay, so basically it is an encryption and decryption cryptography, like we have to firstly the plain text, or we can say that the plain request, then we passed with our secret key, and after doing some coding and some working and some loops, generating multiple loops and performing various operations with our secret key along with the plain text, or I can say that the request, then one 56 bit output is generated, and this output we can called as the HMAC signature. Please, okay, let me show you something. All right, okay. I use this diagram to explain about the HMAC security, HMAC SHA algorithm. So, as you can see here, this is the box, or we can say that this is the working main working part of this algorithm. So, here comes the data like this. This is the data. Basically, I can say that it is a box, and after doing some operation, it generates some output. And uh, we uh, we really does not care about what are the algorithms, what are the functionality and operation it does to generate the output. Basically, we just understand what is the input and what is the output. So, and what is the flow of this HMAC algorithm. So as we can see here that there is a data, and the second one is the secret key. That secret key, like that secret key and data mixed together in this HMAC SHA256, that is SHA256 is the internal part, is the actual part which does the operation, and HMAC is called as the outer body. We can say that under SHA, HMAC under SHA256 is under HMAC algorithm, it is a part of it. So uh, the secret key and data mixed it together and perform some operation, and it generates the 56 bit hash. So not 56 bit, it is so it is not I am confirmed that what is the value, I think it's 64 bit, not 56. So 64 bit hash signature generated. So, how we can implement this in our security purpose of in our validation service? So, assume that we get some request, like some fields or some data from our client or anyone that calls us, that invokes us with our endpoint. and we he it sends some request to us. So, how we can find that the request we got is not tempered, or we can say that the integrity of that data is not destroyed, or it does not affected by any intruder, as the world is growing, and there are so much intruders and the hackers which can tamper the data, and as we are building the payment system, so it is very risky. Without security it is very risky, because we are uh, interacting with the payments and the transactions and doing some stuff like that. So we have to maintain some very strong security, that the data is not, the integrity of that data is not harmed. So for that, like, let's take an example that we got the some request, and how we check that the integrity of data is maintained. So for that we use HMAC in the both side, the client side, and we also use this algorithm in our side also. So the client also generates its hash mac signature by doing some operations with HMAC-SHA256, and it generates the hash. Okay, what data wants to pass, what data they wants to pass us. They basically first converted into a standard format like JSON or anything else. Basically we are using JSON, so it converted into the proper parsed JSON, and after that it generates its corresponding hash map, and along with the request they should send us the request body, like the fields, and HMAC also, with which comes with their data and the secret key, which is only available to them as well as us, not anyone else. They can have the secret key and we can have the secret key. Only 2% are eligible to have that key, otherwise the key is compromised. So they generated the hash, we got the request, then we also generated the HMAC signature, that is hash, and we compare with our generator's hash and with their hash, which comes along with the request body in the header of the request. So when the both hash is equal, we can compare doing some if else and some operations. If the both hash are equal, the data is same, means the integrity of data is not harmed. The actual data we got, that is sended by the client. So this is the working of HMAC SHA. So how we can implement this? Means what are the secret key? What are the secret key we used? What are the secret key they used? Means they both the secret keys should be same, or how we can do this multiple operations and get this HMAC signature. So for that SpringBoot provided some default classes and methods that make this implementation very easy. So this is the functional part, that how we implemented the security, means HMAC SHA we used, and to maintain the data integrity, and the secret key we have and the secret key client have is same. Firstly we pass this data into a standard format, means the format is also same. If there is any difference between a single space, then the hash signature will be changed, and after, when the hash signature is different, we simply discard that request. We simply throw some error and like unauthorized access, and we just discard it. So every time we can't, so we have to convert it into a standard format. So now I'm going to uh, demonstrate what is the technical part of it, how we are implementing that. So let me open it, my Spring Tool suite, and I'm going to here. First, I have already created the security package, and in that I have uh, implemented all the uh, useful classes to generate HMAC-SHA. What are the classes? I'm going to explain one by one. So firstly, let me explain about the controller part. It is a create payment. Okay, it is a create payment that it gets some request. So firstly, I want to uh, show you all what is the payment request, what are the structure of the payment request. So let me show you the payment request structure. This is the payment request structure. Okay, so basically we got the three things, and it is not just the three things, it is the user defined objects. So the payment request consists of user and the payment, and the user consists of the these five fields, like the end user ID, what is the ID of the user, his last name, his first name, email and phone number. Okay, so this is the user details, and the second one is the payment details, like this, the main thing. So we have to check these are the mandatory fields which we want, which we compulsorily want to process or call the PayPal APIs. It is not optional, it is compulsory. Okay, so these are the fields which we worked on the payment provider service also. So currency, amount, brand name, and return, local, uh, cancel. These are the mandatory fields, and we want this all the proper valid inputs by our e-commerce side. Okay, so this is the payment structure, payment request structure which we got, and after that the standard protocol that we can't use directly the POJO object, so converted into DTO, corresponding DTO. Then after by using model mapper as we done it earlier also, and this DTO is passed to create the payment service. Okay, so basically we are doing the logical and the business part in the service layer. So get into this. Okay, function 3. So basically it is our interface, and here we implemented payment service. Okay, so this is the main part. So here we handle the exception, but for that, where the HMAC security takes place, it is a quite a critical job to do, that where to handle or where to check. So firstly, before the controls comes to the controller of our project, before that, in filters, the Spring Boot application filters, we should handle the validation, or we should check the request integrity before the control comes in the controller. For that we use the filter. So firstly, the let me side up the concept of the filters. Let me firstly finish the HMAC filter only, HMAC-SHA token service. Okay, so um, here it is. Okay, so this is our HMAC-SHA, and this is the HMAC-SHA main main code of this. So we have created the service IMPL class also. That is, this is the main class in which we generated the two fields, generate HMAC signature and verify HMAC-SHA signatures. There are the two fields. There are two methods. First is generate the HMAC, and the second one is compare the provided signature with our generated signature. Basically, these two methods done this one. So let's go into under these methods. So here it is. So Let's go through these generate HMAC-SHA signature. So here it is, the secret key, which is hard coded here, but for in future we kept in the safe place that nobody can access it, like in AWS manage files, and it is secured there only. It is not a good practice to provide the secret key here. So it is just a testing purpose, so I kept it here only. Now generate HMAC-SHA signatures. So let's understand about this method, what this method do. So we have simply created the HMAC-SHA signature, which takes the data means the request. Data here is the only the request we got. Okay, means we converted into a typical string, and they input a request structure into the string and pass it here, that can generate its corresponding hash. So we got the secret key. Here it is the signature, means we use here try catch block. So for the range or for the accessibility, we defined it here as a null. So we used here the mac class. Mac class provides us the methods to create the HMAC-SHA signature. It is in the Java xcrypto.mac package, and the secret key spec is in the crypto.spec.secret key spec. So we are simply in try catch block because it can throw exceptions, so we handle it here, and it just we use the mac, create its reference variable, and mac.getInstance pass the constant HMAC, that is the value of HMAC-SHA. It is only the value, it is a constant value of HMAC-SHA. I can show you where it is a constant, so I have defined it here. This value, it is a fixed, it is a constant, so I used as a constant. Now, all right. And the second one is the secret key spec. It is also a class. We generate its reference variable, create object, and pass the secret key. This secret key dot get bytes, and the HMAC-SHA we use, that is the constant value, creates us with we passed also the secret key. And after doing some byte hash, call the do final method data dot get bytes, and we basically encoded here with, we got this value here only, base 64. As I say before, it is a 64-bit value. So okay, it is continue. So this method, after doing the do final dot get bytes and base 64 that get encoder dot encode dot to string, basically this gives us the signature. So just this much is code to generate the HMAC signature. Pass the secret key, pass the data, and it generates us after doing 2-3 calling some methods of the classes, and generated the byte and converted into the string only, that encode to string converted into string. Basically it is a byte form, so it converted into two string. So it just give us the HMAC-SHA signature, and if there is some error, we handle it like this: no such algorithm, exception, or invalid key. So this code generates the HMAC, and the second code means the second method verify HMAC provide the data. This data that provide here only, we did provide this also, and this data, basically we used to call this method, not this generate method. Under verify SMAC, we call the generate method. So basically the main we are going to call this method only, and provided the our provided signature and the data, and after calculating, and basically here is the simple dot equals method to check where are the both the signatures are equal. If the signatures are not equal, then we return false here. means invalid signature. So it is the complete code of the generating HMAC-SHA. So this code should be placed, or this code should be executed before the controller. So before controller control reaches to the controller, it should be executed. So for that we introduce here the filters of string security. So there are various filters, and we kept this spring this HMAC-SHA security filter. We convert it into a filter, and that filter is going to placed in the section of the filters in the middle of the before the authorization filter. We placed that customized filter before the authorized filter, and that filter going to check whether the provided signature and the R generated signature is same. If there is same, the control further goes to the controller after doing some mm, process, and if the signature is invalid, then the process returns back the response with the invalid signature and the authorization fail error. So for that we use the HMAC-SHA filter, customized filter. So here it is the code of a customized filter like this. This is basically we have extend the once per request filter, that is basically a filter, and customized it. We basically call this HMAC-SHA service and call the validation like this. I can show you where it is here. Just this. We call this. If it returns true, we do some further things. If it is invalid, then we do some further things. So firstly we have to understand what is this filter. Let me explain about this filter, customized filter also. So basically we made our HMAC customized filter, and we placed it in the right place of this filter, that is before the authorization filter. Authorization filter is a filter which authorize all the input request, we can say that. Then this gives us the method do internal. It gives us do internal, do filter internal. It is a method of once per request, which are we have to override because we extend this. It is an interface, I think. So we got the here the three parameter request, response, and filter chain. This is the filter chain we create it, and we have to further continue the flow. So the filter chain, we do not disturb the chain of the filters. So after placing it, the execution should be in the flow. So we use this filter chain, and throws exceptions. It is also throws some exception. So we want it here, and firstly we got the request in the headers dot get header. It is the provided HMAC signature. Then we got this if HMAC errors, signature is null, so there is only error, so we don't go further, just show the exception. These are the exceptions which we created. I am going to talk about it further. So let's understand this. The wrapper class also I am going to talk it about in some time. Now this is the filter. Okay, so it gives us the we firstly standardized it into a proper, as I say earlier, that it should be um, in the standard format, means the in that for the format that the client converted and then generated the hashmark. We should do the same thing only. If there is any different, the HMAC signature would be different, and the valid requests also become invalid. So for that we converted into a standard, means the separation of the spaces. Then the string should have no spaces. So we have made the method here that get normalized JSON, means parse the JSON like without any space, and converted into the JSON string only using the JSON library. Okay, So after that, just we call this, and if it is valid, then the HMAC is calling the next filter. Means here it is the filter, like here we use this, okay, this filter. And these are some also codes which it should be executed. There are some users name, there are some password, that the password is not mandatory, so I give it null here. And after that, we used to tell the Spring that is authorized, it is authorized, and uh, make it authorized and continue the flow of the program. So for that we used here the class authentication class, do a new HMAC authentication token. That is our only class. I think we have created here only HMAC authentication token. Here it is the class. We have authorized it. Abstract authentication. Here it is the old code which wants some credentials and principal. The main thing is set authenticate is true. This is the very important. This is the very important. Let me mark it. This is the main purpose. The ID and the credentials are not that main here, but the main thing is the set authenticated it is true. This is the main part. So let's go back, and we just here, okay, here it is the filter. With just some authorization, set security context holder. This is the pre-built response to handle the filters only. And the main thing, now we created the filter, we tell the Spring Boot to authorize that request when the authentication is true, and if false the authentication is not true, and it responds as the unauthorized. And we have to place this filter into a right place. For that we created the config file like this, security configurations. And here I can say you, this is the main thing. This is the placing of our filter. Add filter before authorization filter. As I say before, that before authorization filter we kept this filter. And these are some stuffs of the security related purpose which we talked about earlier. So in next video I'm going to talk about this security, Spring security with the exception handling only, because the video going to be quite long. So this is all the demonstration of the HMAC-SHA256, how we implement, what is the working, and that's it. Thank you.